let me just introduce myself. So I'm Amar and I'm associated with UniNets since 4 years. If I talk about my experience, so I have 15 plus year of experience. I have experience on network security, okay, and I have experience on cloud. So I do teach here different batches like Checkpoint, Palo Alto, F5. Okay, so in F5 I'm handling all the module which is ASM, GTM, and LTM. And I do have experience on the cloud as well, right? So I do have experience on Azure cloud and I do have experience on AWS cloud, both as well. So this is brief about me. You might have already learned about different module of F5 in LTM. Okay, so in F5 we have different types of module. One is the LTM, that is a local traffic manager. Other is a GTM, which is nowadays known as a DNS. This is a global traffic manager, which is managing the DNS request. Other we have ASM, AFM, APM. So these are the different modules. Okay, so here we are going to cover DNS module, and I would let you know the why F5 is required to manage the DNS services. However, that is managed by the any other DNS server, but why F5 is required. So we'll understand that. Okay. So let's see. Let me just talk about the course, and after that we will see that why DNS is required. So in this course, we are going to cover basic things. For example, basic to advanced we are going to cover. So we will talk about what is the DNS, and we will see that how DNS is being deployed in any organization. Then we will talk about big IP DNS services. We'll discuss about global server load balancing. This is one of the mechanisms to manage the traffic, global traffic. And then we'll discuss about data center and server object, what all the objects we have on the F5. We'll see the DNS virtual server, DNS pool, wide IP, etc. So these are the major things that we are going to cover.
Okay.
Now moving to next, which is why DNS is required. Okay, and we will focus. Our focus is more around the DNS services because we are going to learn F5 DNS module. So we'll understand what is DNS server and why it is required. Okay. So if I say that, have you visited any website last few days with any IP? With the using of IP? Last few days, I mean 3 or 4 days.
No, I only use .com IP URL .com like.
not IP. Okay.
Yeah, not IP.
Why you are not using? Because it's difficult to remember, right?
Yeah, remember, and it's not familiar on .com like URL is very familiar and easily rememberable.
Name is more familiar and not IP, right? So yes, that's why we are using IP addresses. I mean name, not an IP addresses. So yes, the answer is if you not visited any website with that name, okay, that's great. Then we have to learn this DNS services, F5 DNS services. Now, if we talk about the domain name system, what it does basically, this is a hierarchical design and decentralized naming system. Okay, so this is kind of naming system. Okay, which is this naming system is stored on DNS server. So whenever any PC is requesting for any website name, okay, by default PC required IP to communicate. This is doing IP to IP communication, but for a user, this is not easy to remember the IP, and that's why there is a user-friendly name has been created. So whenever any user is visiting any particular website using website name, so the query first go to the DNS server so that it can resolve the IP, and once IP gets resolved, the PC would be direct approaching through IP, and then it would be able to access particular website or particular URL. And that's what DNS does basically here. A DNS maps name into the IP. Okay, So whenever you are browsing for any name, it would provide the IP, and you can access that particular system via IP. So this is the decentralized. That means this is not, the DNS server is not in any central location. This is a distributed. It can be in on premises. It can be on the root level, or it can be on top level domain. So this is decentralized. But the main work of the DNS is to resolve name into the IP. And the reason is the user is more familiar with the name, okay, but not with the IP. So that's why DNS service came into the picture. Now, if I talk about name resolution, how name resolution is happening. Overall, there are 10 steps happening for any name resolution. Let's say this system is trying to browse www.beta.example.com. So its query first check on its local system. Actually, there is a local system, that is a host file. You might have heard about that host file. First of all, his query gets checked on the host file, whether on host file against this beta.example.com is there any entry or not. If there is any entry, it would get the IP. If not, then it would check on the local DNS server over here. So maybe local DNS server you would see in the organization that there is a local DNS server. So it would check the local DNS server, that it would check like, do you know what is the beta.example.com? What is the IP of beta.example.com? If DNS server, local DNS server knows that, then fine, it is going to reply. But if doesn't know, this doesn't know, so it would send that query to root server, which is dot actually. This is dot. This is a root server. So his query would go to the root server over here, and it would the query would go to root server, and it would ask that, hey server, do you know what is beta.example.com? Then root server is going to reply, I don't know, but I can try to ask .com. .com is nothing but this is a top level domain, so it would try to ask to .com. Okay, so .com could be authoritative server to reply this. So he's now the query back to this, and then the local DNS server sending that query to .com. That, do you know what is the beta.example.com? So it would say, I don't know what is the IP of beta.example.com, but I can try to ask entire things. Okay, and then this would go to this would ask you, I mean, it would try to ask that the query is going to example.com over here. So it would give the IP of example.com, give the reference that you can ask this to example.com. So now query would go to the example.com over here. Then this is going to generate the query to the example.com for answers. And then this is going to give the reply that I don't know. I mean, it would give the reply that this is the this is the better server that from that would have asked the I can say that would reply the exact query. So now what would happen? Now this DNS server is sending that query to beta.example.com, and then beta.com example.com is going to reply with the IP to this local DNS server. Local DNS server would create the cache on this, okay, for that reply, and would reply to this system as well. So system would get the IP of that beta.example.com, and wherever it is located on the internet, okay, it is going to reach over there directly. So let's say beta.com example.com is here. Is here, which got the IP 200.0.0.5, something this IP. So what would happen? Now traffic would go to this, I mean, this beta.example.com, whatever the DNS server is, it is going to reply with this IP to this IP, and then host would directly try to access this public IP. So this is overall the query work Okay, this is overall the DNS work. So if I talk about in DNS resolution, so how DNS resolution is happening in first step, my system would try to check on the local host entry. If the local entry host entry is not there, it would try to get the DNS name from local DNS server. If the local DNS server is not able to resolve, so query would go to root. Root would be giving the reference to top level domain .com, .net, .org, like that. Since this is .com website, so it would go to top level domain .com website, and then .com is giving the reference to actual website, which is example.com. And in if the example.com there is subdomain, okay, so it would be sending to that subdomain, and then subdomain is going to reply actual IP, and when system get actual IP, it would be able to reach there. So this is overall query.
Like how can we find the so all these traffic flows or the communication is happening between the local DNS server and the other root and top level DNS server, not
Right.
not with the client.
Not with the client, because on client, what is we have configured DNS, right? So if client doesn't know that, then this local DNS server is going to uh, create the query against you.
Okay. And how do we know like what is our local DNS server from? Like is it Google 8.8.8 or something else?
It would be configured on system itself, right? So on the system where you configure the IP, it would
Okay.
get the DNS local DNS server, maybe local DNS server or maybe any public DNS server. Okay.
Okay.
So like public DNS server is 8.8.8. So it may go to there as well.